Hi, this is King of Review. If A and B are square matrices of order 2, satisfying A times B times A equals A, find A minus B. And we're given what matrix A is. So let's start out with the equation A times B times A equals A. Now what we want to do next is multiply both sides by A inverse. So we have A inverse times A, B, A. And this is equal to A inverse times A. Now I want you to remember that if we have matrix A times its inverse, which is A inverse here, this is going to be equal to the identity matrix. Now, if you remember, the identity matrix has ones in the main diagonal and zeros elsewhere. And one property about the identity matrix is that if you have a matrix, let's call it A, and you multiply it by the identity matrix, you end up with the original matrix A. You can also have I, the identity matrix, times A, matrix A, and you will still get matrix A. So let's keep in mind this information when we solve the problem. So A times its inverse will give you the identity matrix. So where do we see that? Well, we see that here. We have the inverse times A, so we know that this is going to equal the identity matrix. And we also see that here. Inverse of A times A. So that is also going to equal the identity matrix. So now we have I times B times A, and this is equal to I. Now you remember that if we multiply a matrix by the identity matrix, you get the original matrix. So now this will become B times A equals I. Now let's solve for B. We want B by itself, so we want to move this A over here. And we could do that by taking A inverse. So B is equal to A inverse times I. And we know, again, looking up here, if we have matrix A times I, we'll get matrix A. So we know that B is equal to A inverse. So what is A inverse? Well, we were given A up here. So we know we're taking the inverse of this matrix here. So we represent that with the -1. And how do we find the inverse? Well, if we have matrix A, let's say it's equal to A, B, C, D. A inverse, this is going to be equal to 1 over the determinant, and the determinant is the main diagonal, so A times D, minus the product of the entries in the other diagonal, so C times B. So 1 over the determinant times the matrix. Now A and D switch places, so D is up here and A is here, and then we take the negatives of B and C. So let's set that up here. We're taking the inverse of A. So we have 1 over the determinant. The main diagonal is 2 times 2, and then we're subtracting the product of the entries in the other diagonal, so 3 times 1. And now let's set up the matrix. The 2 and 2 change places, but they're both 2. And then we take -1 and -3. So let's work this out. We get B is equal to, so we have 1, this becomes 1 over 1 because 2 times 2 is 4 and 3 times 1 is 3. So we have 1 over 1, which is just 1. So this is equal to matrix 2, -1, -3, and 2. So now we know what B is. So now if we have A minus B, that's what we're asked to find, A minus B, we know what matrix A is. So that is 2, 1, 3, and 2. That was given. And then we're subtracting matrix B, and we solved for that down here. And that's that's positive 2, negative 1, negative 3, and 2. So now if we subtract the corresponding entries, we have 2 minus 2, that gives us 0. 1 minus a negative 1, that gives us 2. 3 minus a negative 3, that's 6. And 2 minus 2, that gives us 0. So this is our final answer, and this is letter C. Thanks for watching.